Hello everyone, in this video we will see two-way ANOVA analysis using SPSS software. Before doing two-way ANOVA analysis in SPSS, we will go through few basic things and we will see the example, and then we will go to the SPSS software and we will perform the analysis. So ANOVA is analysis of variance. It is a just extension of t-test. In the t-test, usually we compare the mean of two samples. If we have one more sample, then in that case we have to conduct multiple t-tests, which will result in compounding effect of an error. So it will give higher type 1 error alpha than that we have set for each t-test. For understanding and performing two-way analysis in SPSS, let's take one example, tray drying. So drying, we all well aware of drying technology. It has been used for various fields. So drying in technology can be affected by the various factors. For understanding now, we have taken the three factors, factor 1, factor 2, factor 3, and these are the temperature, air velocity, and thickness of sample. So these factors are also called as categorical variables or independent variables. So there will be impact of these factors on the drying rate, so which is called as continuous variable. We can also call it as dependent variable. So each factors can have multiple levels, or we can say multiple groups. For example, temperature, we can have temperature of various level like T1, T2, T3, and they are 60, 70, 80 degrees centigrade. In the t-test, we usually do the compare of two groups, T1 and T2, and that will be done in the SPSS independent sample t-test, where we compare the mean of two groups. Just like that, if we have the air velocity, effect of air velocity on drying rate, so in that case we will take two velocity, that will be done by the t-test, independent sample t-test. In the same case, we will compare the group means of, we will compare the means of two groups. So if we have one more level, or we can say group, then we have to perform one-way ANOVA analysis, and where we compare the multiple means, if we have more than two groups or two levels. Just like that, if we have multiple level in the case of temperature, same we have to perform the one-way ANOVA analysis, where we compare the multiple means. But to do two-way ANOVA, we have more than one factors. For here, if we have an effect of temperature and air velocity, in that also we can have multiple levels. So in that case, we have to perform two-way ANOVA analysis, where we compare the mean of two independent or categorical variables. In that case also, if we will see the effect of velocity and the thickness of sample, we have to perform the two-way ANOVA analysis. So what we get from two-way ANOVA analysis? For now, if we have the drying and we have two factor, temperature and air velocity, and we will perform two-way ANOVA analysis, then we will get out of the data is whether the factor 1 have effect on dependent variable, that is the drying rate, or whether the factor 2 have an effect on the dependent variable, or we can say that is there any interaction effect of factor 1 and 2 on the dependent variable. So what will be our hypothesis? The null hypothesis will be, the first null hypothesis will be there is no significant difference in the dependent variable due to factor 1. So accordingly, there will be alternative hypothesis, there is a significant difference in dependent variable due to factor 1. So again, second null hypothesis will be there is no significant difference in the dependent variable due to factor 2. Correspondingly, there will be alternative hypothesis. And third null hypothesis will be there is no significant difference in dependent variable due to interaction effect of factor 1 and 2. And accordingly, there will be alternative hypothesis that will say that there is a significant difference due to interaction effect of factor 1 and 2. So for doing hypothesis, there will be certain assumption, and what it will be, so that our data should be normally distribution. And second, these are the major assumptions I am mentioning here. So second will be the homogeneity of variance, that will be checked by Leibniz test. And what will be the assumptions? Sorry, what will be the hypothesis? That the null hypothesis will say that variance of all groups are equal, and alternative hypothesis will say that variance of all groups are not equal. For doing the SPSS analysis, we will take this example. So we are doing the drawing experiment where we have two independent factors. One is temperature and air velocity with 3 levels. So temperature having 60, 70, 80 degrees centigrade, air velocity 2, 3 and 4 meter per second, and one dependent factor, that is a drying rate. So we will have total 9 experimental group. But remember, doing analysis in SPSS, we need triplicate data. So our data table will become like this, and we will have total 9 groups. So each groups we have to perform in triplicate. So for doing two-way ANOVA analysis, I have formed this dummy data. So we will perform this data in SPSS software, and we will see how we can do the two-way ANOVA analysis in SPSS software. Let's get into the SPSS software. So this is our SPSS software interface where we can see the variable view and data view. So as we know that we have 3 variables, 2 is categorical variable and 1 is continuous variable, that is dependent variable. So first we will see the categorical variable. First one is temperature and second one is velocity, and our dependent variable is drying rate. So temperature having 3 levels, so we will assign the 60, 70, and third one is our 80. We'll add it just like that. Our velocity having 3 level, so first one is 2 meter per second, second one is 3 meter per second, and third one is 4 meter per second. So after adding this one, so we will measure it. So these are our nominal data, and our dependent data should be continuous data. So we will see here that this become, now our data is arranged like this. So we have all the temperature, 9 temperature because of 3 velocity. So we'll arrange here like this. Okay, as you can see that I have set our experimental data condition as we have in the Excel. We can flip it to see the input value. Now we will paste here the drying value which we have got from the experiment. We'll copy this one, we'll paste here. Okay, our data is ready for analysis. So we will go to the analysis. So here we can see there is 2 things. So general linear model, we will go into this and go to the univariate. So as we see here, so our dependent variable is our drying rate, we will put it there, and temperature and velocity our fixed factor. So in the case of model, we do not have to do anything. In the contrast, nothing we need to do. In the plot, we can see the effect of temperature, velocity. We'll put the velocity on horizontal and temperature on the separate, and we will add it and continue. In the post hoc analysis, as we have to see that effect of temperature and velocity. So we'll put it there, and then we will do the Tucky test. So there is two things. If we have equal variance as we assumed, so then only we have to do this. Otherwise, if we do not have equal variance, then we will usually follow this one. We'll go to the estimate margin means. We can put the temperature, velocity and interaction effect and continue. One more thing, so we'll compare the main effect. We'll put it to the Bonforni, and in the option there is a descriptive analysis. We need to see the effect of size and homogeneity test. It is must to perform, and then we will click OK. Okay, so we got our result. First, before doing anything, first of all we will see the leveling test as we have explained there. So it is showing if significant. So as this is significant, let's get back to where we have discussed this one. So as we seen that the leveling test shows there is significant. That means we fail to reject null hypothesis. That means all the variance of all group are equal. So that's why we can perform the Tukey test. Okay, so we passed our assumptions. Now we will see our remaining data. So this is the between group test. We have temperature, we have 3 temperature, 3 velocity, and total number is there. And descriptive analysis. So each temperature having as per each temperature we have 3 velocity, and there is a mean standard deviation and the number of experiment. So we have seen this one data, and this is the test. So we can see the effect of temperature is significant as the p-value is quite less than 0.05. Effect of velocity is also significant, but if you see the effect of interactive effect of temperature and velocity, it is more than 0.05. That is not significant. So our interactive effect is not significant. Let's move see the other data. So in the two-way ANOVA analysis, this is the 3 temperature. So this means are the overall mean of 60-degree temperature data irrespective of velocity. So 3 temperature, 3 means. So next data says the pairwise comparison. So we'll see the effect of temperature in compared to others. So 60 degrees and 70 degrees. So it is a significant. In all the cases we can see that with the increasing temperature there is a significant effect on the drying rate. Let's go to the velocity. Just like temperature, the velocity, these means are the mean of all 2 meter per second data irrespective of temperature, and in compared to velocity with the other velocity, air velocity, so there is a significant in the each cases as we can see here. And if we see the combined effect temperature and velocity, we can see that all the cases the combined effect is not significant. As our post hoc analysis, the Tukey test also says that there is a significant effect of temperature as the Tukey HSD. So each with the increasing there is a significant difference, and just like that the effect of velocity is also there. So with the increasing velocity, the each column represent the significant difference is there with the velocity. Okay, so interpretation of our experimental data is the effect of temperature. So we have seen there is a significant difference between the means of different temperature. So that is our p-value is less than 0.01. And there is a significant effect of air velocity also on the drying rate. And in terms of interaction, what we have seen that there was no significant effect due to interaction effect, and that we suggest that effect of temperature on drying rate does not depend on air velocity. So this was all about the performing two-way ANOVA analysis using SPSS software. Thank you so much.